All right, CJ, this is part 2 of the notes today. We got some error analysis, some common student mistakes that I've seen, and then also we're going to evaluate expressions by plugging in numbers that they give us. So the first one, describe and correct the error in trying to evaluate the variable expression, excuse me. So we have 2 plus 3 squared times 3 plus 1. The first step they did was make this 5 squared times 4, and then 25 times 4 is 100. It seems pretty logical. But it looks like they added first to get 2 plus 3 is 5. They also added this, 3 plus 1 is 4, and then they said, oh, I'll make that 5 squared 25 and 100. The error is they didn't follow Pemdas. So Pemdas says that they should have done exponents first. And yes, you're writing this down. They should have done exponents first. So if I rewrite this problem, 3 squared times 3 plus 1, this would have given us 2 plus 9, because that's what 3 squared is, 3 times 3 plus 1. Then multiplied, and what would we have multiplied? We would have multiplied, sorry, can't spell today, multiplied. We would have done 9 times 3, which is 27, so 2 plus 27 plus 1, and then added to get 30. Just 2 plus 27 is 29, plus 1 is 30. So I want you to do something similar after you're done with the video to correct the problem. So go ahead and write it over here like it should be. So we'll just leave this right now as a minus. So 17 minus 3 squared minus 2. So see what they did wrong. Remember, you want to follow Pemdas. Excuse me. And I'm saying at some point in this problem they did not. So the incorrect answer is 16. You got to tell me how to get the right answer. All right, so this is kind of really like level 3 of order of operations, and it's taking numbers that they give you to plug in for a variable. So what's a variable? A variable is a number that we usually don't know. It's a placeholder, correct? So we have this expression, which is nothing but a bunch of variables, and they're saying, well, hey, what if I told you the variable equaled -6 and the other variable p equaled 5? What would this expression become? What would it add up to? And so what you need to do is you need to plug in, all right? We're going to substitute or plug in, which is the fancy, which is the simple term for substitute, with parentheses. So we have m squared is really going to be -6 squared. And when I plug in, I always like to use parentheses just to know, like I'm saying, hey, m, I replaced it with a -6. And p, that is 5. Notice how, again, I use parentheses. And m, which is -6. So what have I done? I've rewritten this expression, but instead of variables, I've put in the exact values that they gave me, right? M was -6, that's why I have -6 squared. P was 5, that's why I have 5 there. And m was -6, that's why I have -6. So again, I'm going to use Pemdas. So Pemdas means I use parentheses first. Now, I don't have any true parentheses here. These parentheses are just saying, hey, these are the numbers that I plugged in, so none there. I do have exponents, though. -6 times -6. Maybe think about it as -6 times -6 should give you positive 36, right? So 36 plus. Now, this is not 56. This is not -1. Remember, you are multiplying these. 5 times -6. That gives you -30. Remember, we're switching between all these different rules in our head. So we've just done an SSP problem here. We just did a DSN problem here. And then look at the end of this is a DSSL problem of 6, right? So continually switching between all the different rules of adding, subtracting integers, multiplying, dividing integers. Got to be sharp with it. Number 10, let's do together. So again, let's put down Pemdas here. And let's start with plugging in. Now, when you have parentheses, it's going to be super tricky to plug in. But you just got to be super careful with it. So you have -5. Now you're going to plug in an x. So what is x? X is 3. So 3 plus what is y? Y is 3. So they actually works out because they're both 3. Now watch. Those are the plugged in numbers. I'm going to close it up with the parentheses, right? These are the original parentheses that you had. right, divided by 6. So again, I haven't changed the problem. All I've done is replace the variables with what they told me they equaled. So within parentheses, I have to do order of operations. So I can't add these first, I have to multiply them because multiplication comes before addition. So this is still in parentheses, negative 15 plus, and you can now get rid of that parentheses, right? There's no reason for that to be there. Negative 15 plus 3 divided by 6. But notice how I keep the overall parentheses, right? Because I have two operations inside this parentheses. So negative 15 plus 3 DSSL. Why am I doing this first instead of dividing this? Because it's in parentheses. So I get negative 12 divided by 6, and now this is a DSN, right? We switch from DSSL to DSN, going back and forth, back and forth. Got to be on your game. So this gives us negative 2b. And notice how they have 2 as an answer choice, right? So you could just say, oh, 12 divided by 6 is 2, and you would be wrong, right? All because you forgot the negative. Negatives matter, right? Oops, sorry. Let's scroll down. I'm going to do 11 and 13, and then I'm going to let you guys do 12 and 14. So let's plug in with 11. We have negative 1 plus n squared, which is negative 4. So negative 4 squared minus 1. So Pemdas says, all right, I do parentheses first. I don't have any true parentheses here, right? This is just saying, hey, I'm negative, and that's what I plugged in. I could have put this negative 1 in parentheses as well. So I go to exponents. So negative 4 squared is not negative 4 times 2. It's negative 4 times negative 4, right? So that gives me 16. So I have negative 1. Again, I don't need the parentheses anymore. Plus 16 minus 1 or plus negative 1. Plus negative 1, right? So adding this up, I get 15, positive 15 plus negative 1. DSSL gives me an answer of 14. Again, why do I have this initial parentheses? That's just saying, hey, I plugged that in for m, and then why does it disappear? It's because there's really no reason after I'm saying, hey, I plugged it in, to keep it, right? In some cases, it's nice to keep the parentheses, like here, to know that, hey, I need to multiply these two. Like here, I need to multiply them too, but like after I know that, oh, I'm just going to be adding that, like I don't need to keep it in parentheses, okay? And number 13. So I have x, which is 5, so plug it in with 5, plus y, which is 6, divided by 6, minus y, which is going to be 6, plus x, which is going to be 5, divided by 5. Wow, whole lot of stuff going on there. So Pemdas, do I have any true parentheses? No, I don't. Right? Do I have any exponents? No, I don't. How can I tell if I have true parentheses? I can scan this original expression and see if there are actually any parentheses in there. Multiply or divide from left to right, whatever comes first. So if I scan, I see, this division comes first. So it should be 5 plus 6 divided by 6 is 1, minus 6 plus 5 divided by 5. Right, so I scan again. Do I have any more multiplication or division? Division all the way down there at the end. So 5 plus 1 minus 6 plus 5 divided by 5 is 1. I should keep change here, plus negative. 5 plus 1 is 6. 6 plus negative 6 plus 1. Oh, look at that. That's the additive inverse. 6 plus negative 6, they are complete opposites. They add up to 0. So 0 plus 1 gives me 1. All right, so you guys need to be very careful in plugging in for 12 and 14. Also make sure that you finish this error analysis problem up at the top, and then back on the front, make sure you finish any problems that I did not do, 2, 4, and 8. Get to work.